Thanks. Welcome again to this session. I think it's something like the 10th session already in this awesome 24-hour Neotys Pack conference. I hope there's a special prize for anyone who watches all the sessions live. So, Henrik, I hope you're tracking this. So what I'm going to talk about is really about what I see as the continuous performance engineering concept that we have here with Altersis Performance, and specifically how it relates to the test scenario design, which I think is one of the still has always been one of the more awkward, frustrating, inconvenient parts of performance tests, and probably remains so to some extent, even in this new world of continuous performance testing that we're all coming into. So that's what this slightly confusing title refers to. I'll start by looking at some of the challenges that we're still facing for performance testing, and we've come a long way, but we still want to remember the good things, but confront the final challenges that still remain. And in order to look at the test scenario difficulties, I set out to think, why are we having these difficulties that I still see on my projects? Why is it that the classic kind of test scenarios in performance test tools that we're using are still kind of inflexible and causing problems in the project? What can we do about it? And in the end, we have developed a kind of prototype framework, which I will demo to you in a few minutes. So, just as a little bit of background of my thoughts about this. I've had the pleasure of participating this year in a few of the online PAC meetings during the lockdown. And I consistently always say that we always have to remember how I think these are great times for performance testers. Compared to 20 years ago, 10 years ago, and so on, we're finally where we want to be as performance engineers. I think we're in a great position where we are finally making a real difference to projects. And it's at this point sometimes where I appear like an old grandpa and start reminding the kids today that in my day things were so much difficult. We had to enter the test data by hand, and so on. But so it's with this background that I think what used to always be the frustrating classic limitations of performance testing, they have really been attacked in the last decade for sure, and in the last few years in some cases, and major gains have been made. So the most frustrating problems used to be we would be running in a test environment that was nothing like production, and there's nothing we can do about it. The test is not realistic in terms of the test data, the coverage. There's a huge maintenance effort. And by the time that we get to do performance testing, it's too late in the cycle, and so on. So many of us are all well aware of these difficulties, and sometimes we still suffer from some of them today. But like the tide coming in, I think it's been an inevitable wave of progress. For example, with test environments, when we started to get VM capability and then later cloud platforms, and the cost of environments goes down. And gradually, in most companies, the difficulty of making a test environment like production is reduced, the cost is reduced, and we're generally in a much better place to run valid tests that actually mean something. Similarly, of course, the technologies came, the tools came to allow us to do the things that we couldn't do before, where we were testing in black box in the old days with only occasionally getting insights into what applications were doing under the covers. Then, of course, APM tools, analytics tools came in, and we were able to do so much more and add so much more value to the project. At the same time, Agile and DevOps came, and everyone realized that it was really valuable to shift left, connect everything to pipelines. So, and this gave us the emphasis to finally do performance testing earlier, even if it's in smaller environments, and work closely with the developers. And all of these things have led to massive, massive gains. Now I feel like we're, in recent years, we are attacking some of the last thorny issues of performance testing, like the things that the guys in the last few talks have talked about, automated analysis and dashboards for performance test results, things like this, the Captain framework, even the concept of SLIs and SLOs. So the design of things has really improved. Then one of the problems, the challenges that still remains is that test scripts usually needs a bunch of maintenance. So I'm interested to see there's a talk later on from the guys in Colombia about making test scripts update automatically or semi-automatically. So I'll definitely be interested to see what they have to say about it. And of course, tools like Neotys have come in with features to help reduce the time of maintenance of test scripts. And with the Neotys framework and so on, then there's a chance that some of the time that test maintenance effort is taken away. So another problem is getting attacked and reduced. What I'm going to talk about today is one of these other small areas that still annoys me with performance testing, and that is the test scenario design. Even though we are now able to run tests automatically as part of the pipeline from the CI tools, still we have some limitations with the test scenario. So we set out to think, why do we still have these limitations? What can we do about it? And what can we do to maybe bring test scenarios into the new age? So this was the start of our thinking. Driver for all this was my own frustration with the amount of time it is taking to update test scenario. Talking about the classic performance test tools, load runner, JMeter, and so on. So I've listed a few of the points here. I'm talking here about the test scenario, the classic definition as in there are virtual users or threads, and they're usually collected together into groups or populations in Neotys and linked to the test scripts. And groups are grouped together with some kind of common setting. Maybe they're running on the same load generator. Maybe they have a common type of network setting, like to emulate mobile users or something like that. They may have one script or a mixture of scripts or particular data. And that's typically a way that the test scenarios are designed. That works perfectly well for very simple test scenarios. But if you try to model a complex situation, then the test scenario starts getting more and more complex. And what this means is when you can come up with a really complex design, it means it's time intensive and you end up clicking around in the GUI to do this manually to set up all these different settings. Then, of course, because you're doing that, it's very prone to error. The human error of updating 100 different fields, accidentally entering the wrong value in one of them, and the next day you find out that you made a mistake and the volumes of your test were all wrong, and so on. So this is a classic problem that I don't think has really been resolved as yet. The, as a slight aside, there used to be a bug in LoadRunner. If you updated the script in LoadRunner and uploaded it to the controller to run the test, then you had to click on a certain drop-down to refresh the runtime settings. And in the certain version of LoadRunner, when you clicked on this drop-down, the settings didn't get refreshed, and you had to do it twice, or the settings would then not be updated. The number of times this cost us a whole run wiped out because one of the team would not remember this little bug and then kick off the test and all the settings would be wrong. So it's frustrating and it's prone to error. It's inflexible, by which I mean it's very difficult to change these settings. Putting in context, I'm talking about test scenarios I have seen where 50 to 100 different scripts can be involved. Or I've seen scenarios with maybe 30 different groups easily, and the groups are made up of a mixture of different scripts and so on. So it's very inflexible to try to change that design. And of course, this all has a kind of low usability in that it's driving performance test design away from project members getting involved. It's forcing it into the realm of the performance test tool expert who knows how to use this tool and doesn't mind spending 2 hours going through it all again to change the scenario design upon someone's request. So there's a kind of low usability that I feel has been driving us away from working closely together with the project in the Scrum team and so on. The background to this is we were running one of these complex scenarios and rather reluctantly spending 1 hour to update it on a regular basis. And it was carefully controlled with a spreadsheet, of course, defining all of the pacing time, iterations, and so on. And the scenario was set correctly and running correctly and actually hitting more or less the volumes that we wanted to hit to satisfy our project. But then along came another team which was controlling the entry server, a slightly different area to the application we were hitting, and said, well, actually the balance of this load that you're putting on it is not right from our point of view, even though it's creating the right load on your application. It's not realistic for us, and we need for you to make some new scenarios and go through some different volume models, and so that we can try to run some kind of scalability tests, let's say on the entry server. And so basically we had to then adapt our scenario again and again. And I was frustrated because it took so long for us to achieve this. So really there has to be a better way than these manual updates all the time. So this was the driver for this. We looked into it and said to ourselves, what can we do to improve this and make this more automated? And I came up with this user story to show what do we want to come up with. As a performance engineer, I want to be able to update these test scenario values automatically. For example, in a YAML file. Okay, so far so simple. This is something that people are already doing quite a lot. Although we were not doing it in that case that I told you about. But that is relatively straightforward. But what I really wanted to do is the second point, which is be able to run the query which will bring me back some production volumes from a particular time period that I choose, and then automatically update these test scenario settings. And of course, go ahead and kick off the test automatically if I want to do that as well. And then the third point, while we're at it, why not have all of this data about the volumes together with the NFRs, or SLO targets and so on, the test metadata and the test results, monitoring metrics and so on, all collected in one central place, which is what I refer to as the performance metrics database. So a central database that's holding all of our performance information. So the performance metrics database is not a mandatory part, but it's something that we think is very useful. So once all our data is in that database, we can then do whatever we like with it and produce the automated reports and dashboards and compare different runs and so on. So that is the use case that we came up with. But if you like, to make it simpler, we have a use case of project team comes to us and says, hey guys, we had an issue in production last night. We want you to run the tests really quickly with exactly the same volumes, replicate the issue so we can start to investigate it. And in the past, this would have then involved us perhaps half a day of then going and finding out these volumes and updating the annoying, inflexible test scenario with the risk of making these human errors and so on. So that is the use case that we're attacking here. So solution design. We want to run it, be able to automate this. So we're of course running from the CI tool. And we're assuming that we have some kind of analytics tool, or at least some way of querying the production volumes, of course, to pull that data back. So the first part of this is that we need to send the query automatically to our analytics tool to get those production volumes, and the data will be returned, either directly from the CI tool or in some other way. And the scenario design will then be automatically updated, which could be, in the YAML file or wherever it happens to be. And then once that design is updated, the test will be kicked off, again from the CI tool, using the new scenario design data that we've just updated. And the performance test results will be then sent to our performance test database, performance metrics DB, as we see there, together with all the other data that we can harvest. So this is the simple solution design that we came up with. And of course, it's nice if all of these parts on the right-hand side can be all together in one tool, one repository. So again, this is a nice to have from our side. So what we came up with, we've come up with one implementation of this. In fact, we've played around and come up with several possible implementations. But for CI tool, we chose the ubiquitous Jenkins, and on the right-hand side, we are using Splunk because it was there in the projects that we are working in. These two tools are available, so that's an obvious driver. And Splunk is a natural choice in that it's a very good tool for everything to do with data. So, of course, we had the experience to do this in the team. But so this is just our implementation, and this could, of course, be done with lots of different tools as well. For the load test tool, we hook this up with JMeter, and then clearly this could also be done with any load test tool that can be driven from Jenkins, which would be almost any of them. So we had also had a go with some prior implementations of this. And one initial idea that we had was using MongoDB to store all of the production volumes. So there was a regular query, and production volumes were, I think, daily, then written into our own MongoDB database, and then they were pulled out. Also, we had done another one using our own Performance Studio tool, which is a tool that we have developed in-house that is kind of like a framework driver for all this. But certainly better that we can use tools which are available commonly across many of our customers, and that's what we're aiming for here. So, of course, while it looks simple in this diagram, in a complex scenario, there are still a lot of difficult cases to work out. How do we actually do this? And the trick is being able to take the results that are returned from your query, getting production volumes, and translating that into a scenario design. Is not too easy a task. When you think about scenarios with lots of different groups with mixtures of scripts, and in the scripts they have a mixture of transactions, then of course it's not so easy. An easy case where this is really applicable is if we are doing a test based around API calls, where we can have, say, one script or one function is submitting one API call, and there's a kind of one-to-one correspondence, and we can pull that out in production. Then that's a really nice and easy use case for this. But in the end, with the power of Splunk queries, then a lot of different things are possible. So let's give you a quick demo of this. So I need to share to the VM. So hopefully you can now see this VM, and if there's any problems with that, just let me know. What we have in this local VM that I'm running is Jenkins with some Jenkins jobs sitting there waiting. And we have some Splunk with some Splunk apps, which we have written as add-ins to Splunk, especially to do the things that we want. Now, also I should mention this, what we have here is an internal demo of this concept, as I'm not allowed to show you the actual implementations that we have on the customer site for obvious confidentiality reasons. So we have put together a small demo of this for internal, which is based on some very simple test scenario, just to show you the concept. So firstly, what I have on this tab is the Splunk app performance project descriptor. And here we have the test scenario design. So we have, you can select your project, and you can select the test scenario that you want. And this Splunk app will display the high-level test scenario details. You can see them for this scenario on the right-hand side, notably the v user count, test duration, and some other things which are not set right now. So there is space to put your targets, your SLOs, and so on. We have a list of the test cases which are included in this scenario. And so for each test case or group in this case, then we can have the number of users that we want to run that with, and the various other parameters like the ramp up and sleeping, think time, and so on. Underneath that, we have there are different transactions which are included in that script. So that is the test scenario design in the Splunk app. Another Splunk app that we have is a test execution, which is basically providing a test execution dashboard. So we then move to Jenkins, and in Jenkins we have a Jenkins job called Performance Test Designer. Then if I look at the configuration of this, then we have got a plugin in this Jenkins job, which is going to connect to our Splunk database and run a Splunk query. So this query, which we can customize in here, this will be the query, the magic query that's going to return our test volumes. In this case, this is not a real Splunk query because we don't have a real production system to look at. It's going to return some hard-coded stuff. So I can execute that here, and we see it returns some dummy values, which in this case means the total virtual users, 50, 70% of them in population 1, 30% population 2. Then, so then we can then, okay, some issues here. We can then manually update the Splunk project here, and these values will be automatically updated. However, the aim of this is not to do this manually. I have just got this manually because we have, for the purposes of debugging, we have a manual option in here. So there's a flag here that says, if this flag is checked, when this job is run, it will automatically update Splunk scenario with the basis of the search results. If this flag is not checked, then we can run the job and it won't update automatically. So this allows me to then manually update these fields. So let's leave this, go back to Jenkins. Yes, we can leave it. The second part, the second Jenkins job is quite simply a job which kicks off the Jenkins project, so the JMeter project. So we have to give it the path to our JMeter JMX file. And this will be writing into the JMX file with the new volumes that it's received. And this job at the top, the full workflow, that will run job 1 followed by job 2 when I click on build now. So off it goes. Okay. I'm happy to see that it's successfully kicked off the JMeter test. And at the start, which you may have seen for a split second, it ran the query and got these volumes which were returned by Splunk. So if I look yet, so we now see in the Splunk dashboards the test has been kicked off and it starts to show some basic results coming back. Hopefully you got the concept of this. We can leave this to run for now. As I said, this is one implementation which is useful for us as we have these tools on site, and we already have some relevant Splunk queries and so on that can be used to drive this. But this could easily be done for using whatever systems, tools that you have at hand, or even using script. So I can hear people asking, why did we use Splunk for all this when we could have, done this with a bunch of scripts and, updated the YAML file programmatically and so on. And that is indeed the case. But I think one of the use cases for this is that we're working with the project teams, but they are already very familiar with Jenkins, Splunk, and so on, whereas they are not interested in using JMeter, LoadRunner, so on. And so using this, it makes it then accessible to the teams that we're working with. So it's not only about having the technical solution to automate it, but it's a technical solution that will actually open out to the customer, if you like, and help it to get them involved in the whole performance testing process. And ultimately, I could see this becoming performance testing as a service, that we can enable the team to do this themselves, and they don't have to depend on the performance test tool expert anymore. So those are the main points for me. Just to look at this, to put this into somewhat whimsical context, this is our slightly humorous attempt to show this continuous performance engineering vision. So this is kind of like a pipeline showing all the different stages of the process and where performance testing will be involved. starting from the development on the left-hand side with working with developers to try to get their coding techniques better for building performance in before the code is even ready, looking at requirements, looking at architecture for performance, going round clockwise into CPT, continuous performance testing, from the unit level, from the functional testing level, and then into pre-prod, so continuous performance testing, everything that's automated. Going further round into ops, continuous delivery, like APM in production, incident management, all areas where performance has to be involved now. And then, most importantly, the feedback loop, going back from production, back towards dev. And this is one of the areas where this test scenario automation is helping out, giving feedback from production volumes back into the requirements process, and then allowing that to come around into this continuous performance testing. So this is the theory that we are working towards, and to have as many things automated and user-friendly as possible. This test scenario design that I've shown you today is just one part of that. So in summary, test design is a frustrating part. It always has been. I think it continues to be for me. What I propose today is one way that this can be improved. It will reduce the time and effort. It will improve the usability and allow us to run a much more flexible range of test cases, which will help us much more with things like scalability testing or tuning and so on, that we can run tests again and again without having this effort every time. So it's one small step towards a better continuous performance engineering process. Then we can all be happy dinosaurs. So that's it.
Thanks so much, Alan. From our end, we had a small of a technical issue. We just I lost at the office. We lost internet connection while you were presenting. So I missed the demo. I missed everything. I just had the chance to reconnect for your last slide.
Okay, I start again, huh? No problem.
Yeah, I suggest that we redo it again. No, so I think I have to wait for the recording. So could you? Because I was hoping to see the demo because I had the chance to do it. I'm so frustrating because. Well, so could you summarize the demo? Because very quickly, for me.
Yes. So let's share.
Not really the demo itself, but just to summarize. All right. So this.
Yes. So we have the Jenkins jobs still running at the moment. The test that I ran. So in Jenkins we had a plugin, and this plugin will run a query automatically against Splunk, getting the results out, which would be our production volumes, and then update the test scenario design, which is held in the Splunk app, and then it will kick off the load test, which will then be run based on the new volumes that have been updated based on our query. And then, of course, we have a dashboard also in Splunk. So that is the nuts and bolts of the demo.
And the data source that comes from Splunk, so basically you're collecting data from the sort of production environment to get some usage in the one of the index. Oh, okay, got it. And so how do you collect the data in Splunk? So you have like in Jenkins, you have like a sort of a query in Splunk to collect the data, and then parse it and then replace the values in your YAML file?
Yes, that's right. So the query runs, but as I mentioned, this is a dummy query it's not returning kind of real genuine data because I'm not running this on a genuine system. But in the real world, then this query is returning the real values, and we have to parse this. And there is also a manual option for debugging down here. So I can then set the things like the duration, the total number of users, and the percentage in this case, which is the percentage of the two groups. There are only two groups in this case, and I can say, yeah, run this one with 70% and the other one with 30%, and so on. So it's simplistic at the moment, but we intend to develop it further. So it would also be useful to get feedback, anyone that's watching. And of course, we can hook this up to any tool, even though we're running this with JMeter now. And with Splunk, it is not tied to any of those things.
Got it. And so basically here, you're mainly interacting with the number of the user load and the splits between the different scenarios, I guess, or populations.
Yes.
But there was one question from the audience. So what about if I have, so here, let's say if I do component level testing on API level, that will make the job, because usually if you hit the API, most of the time the interface of the API doesn't change every day. So we should not be impacted by major changes. What about if you do like web UI? So I have a web UI script. So how do you, for example, using JMeter or through protocol level testing, or if you have similar to load runner or true client, how would you manage the changes? I mean, if there's a major changes, I guess at the moment this is, this is a first lot, I think, of this of your framework. But have you already envisioned to include more smart updates, sort of the test scripts?
Well, yes. This demo that I'm running now is actually a web UI script, in fact. These are not API calls. So there are, although we haven't looked at the scripts, there are multiple steps and multiple transactions under these JMeter scripts, which are just running against a basic eShop dummy application. So in principle, there's nothing to say that we couldn't run with that. The difficulty is actually in doing the calculation to say, okay, it's very simple if we have API calls only, as I mentioned earlier, and this is a very simple, nice, neat solution. If we have a typical user flow going through online banking application or something, then we have a number of scripts where there might be some crossover or some overlap between the different scripts. So some of them have the same transactions, or they're doing similar steps. And of course, that makes the whole design a lot more entangled. And we haven't got an easy solution for that. But for your application, basically, that is the trick that you will have to come up with some kind of query or calculation that will allow you to come up with the numbers, let's say, for each of the groups or each of the scripts in your scenario. Yeah, it's a difficult problem, but I think it kind of needs a custom solution as well for every project. There isn't one answer to that.
Yeah, got it. So I'm going to enable the webcams of the various pack members connected. So there's Luca, there is Joey and Roman. So I'm going to enable them. And Joey here. And let me ask the other pack member.
User parkeren, we hebben niet gehoord een try catch. Dat heb ik niet aan gedacht. Ik heb dat toen vlug gedaan met hem en dan gaat lopen.
Joey is speaking to someone else. So let me ask first of all, Roman. Do you have any questions for Alan?
Yes, actually, I'm really keen on how it works, like a little bit more in detail. So you're getting you called them volume from production, and you took them in your example from Splunk, right?
Yes.
Yes. And so what the two of you already discussed, that this is probably easier for APIs than it is for web applications, right? But how do you, what exactly do you take from the API? So is it like the requests per second over a certain time frame to get the load, or the rate of concurrency? I also saw you have the virtual users in there. Could you go a little bit into detail about how to get the data? What's the source?
Yes, so in the API case, we had a working prototype where I mentioned where it was actually using MongoDB originally. And so this started with a query to get the volumes of each of the API calls in production. And this is read into this MongoDB database. Once we have that data, then the question for that scenario design is, okay, we have a script which makes this API call. How many virtual users should we run that with, and how fast should we run them? So the pacing or the transactions per hour. And we have the number of calls per hour that we want to simulate. And we also, in that case, queried the time for each of the calls. So we therefore know how many calls it's possible to make, say with one virtual user. So that with that extra information, then there was an extra calculation just to work out what is the minimum possible number of virtual users that were needed to achieve the throughput. And therefore, with API calls, maybe the number of users is usually not so critical. So in that case, I think we're taking just that minimum and running with that. Like I said, with go ahead.
So you're more focusing like on the entire throughput, not more not so much in rate of the concurrency. Or did I get it wrong there? Because you said you don't focus so much on the number of virtual users.
Yes. What I mean is, in the case of API calls, they were not actually coming directly from users for that test. So it was not the users was not critical in that sense. But in this design, we're doing both, setting the number of users, so to speak, or the number of threads, and also there's also a setting for the iteration, pacing, think time, and so on.
I think it's pretty cool. So you're trying actually to wrap it up
with whatever fields are needed. Then for your own project, this is still quite an early prototype. We hope eventually to customize it for whatever fields might be needed.
And how do you deal with the variation that happens like during the day? I'm still not entirely sure how it works, but for example, you have an API, it might be called a lot more during the day than during the night. Are you considering or specifying time ranges?
Yes, so the vision for this, there are various constraints on this, not least that there is not any error input validation on these GUI fields that you see at the moment. So, like I said, it's still in development, but
of course.
we basically want to. My vision is that we are starting with a given period. Let's say the use case I mentioned earlier. Someone comes to us and says, "Okay, I want you to run a test based on the volumes between 2 p.m. and 3 p.m. Last Friday afternoon." And that's the use case for this, that we can then enter that time period in our Splunk query, and it will pull out those volumes. So there's an assumption that whatever you enter in the Splunk query, the time period that you select, then there's the assumption is that you've done that right, and that is the period that you want to simulate. And yes, we're going to then come up with a flat value for that time period, whatever it is. So this at the moment is not dealing with kind of during the scenario changes. But it will allow you to run multiple short scenarios with different time periods or different volumes. That will be then very easy to chain different test runs up, which is the next interesting part.
All right. Well, that perfectly answers my question. Thanks for that.
Thanks.
Any other questions, Luca and Andy? You have any questions for Alan?
I gotta say, I just joined like two minutes ago, which I'm sorry for that I couldn't watch the rest of the presentation because I just switched to another meeting, so no questions from my end.
Luca, no questions?
Yeah, no question from my side either.
Okay. So thank you, Alan. Really nice presentation. I think a lot of people enjoyed it. And again, I was frustrated because I didn't have the live demo. So thanks for showing me after for the Q&A. That was very helpful for me